Kia ora, and welcome to another episode of Beyond GIS. We have a bit of a round table today. The topic we were going to explore was risk management, made easy really, with good governance around data and tooling to get value out of data. We're sitting here as New Zealand's just sort of had cyclone Gabrielle come through and wreak a lot of havoc, particularly up in the North Island. And it's pretty pertinent time actually to think about what data means in that landscape for effective response and then recovery to emergency events. So on that note, I've got a couple of colleagues with me. We've got the other Kurt Joy. He's the doctor, I'm not, in the office. And Santosh, head of platform. Maybe if you both just quickly introduce yourself, sort of what your focus is and what you love doing here at Orbica. Kurt?
Yeah, hey, I'm Kurt Joy, I'm K2, the other Kurt, as Kurt said. So yeah, I'm here to do geospatial analysis, data munging, and remote sensing. And it's kind of that interaction and fusion of all those data sources that I find really exciting.
Santosh?
Hi, yeah, my name is Santosh. I'm leading the platform here at Orbica. So my background is also in geospatial, data analytics, and application development. And currently I'm involved with developing the platform for Orbica.
Fantastic. I was going to say something before you smoking a packet of cigarettes.
I smoke a lot.
You smoke a lot? Yeah. Anyway, let's just roll with it. All right, so maybe if we start, I don't know, we've done various experiences and projects and whatnot over the years, but let's just think about that interoperability, that ability to share and collaborate around data and the associated communication, I think, with it. I don't know, Santosh, do you have any sort of views or thoughts that come to mind straight away, particularly in light of these sort of emergency events that the world is seeing more of because of climate change, to be honest?
Yeah, I mean, in my experience in the past, working on emergency kind of management projects, there's always multiple organizations, multiple entities, multiple partners involved in usually addressing emergency management. And during that time, sharing of data is critical. And how quickly can you share data with each other, and how easily can the data be consumed, and decisions can be made to act on the ground is very important. So the time to response from the time the data is collected all the way through it's disseminated and the action happens on the ground is very important. And usually there are a lot of bottlenecks in the way because different organizations collect data differently, they organize and store them differently. This is always a bit of an overhead on converting those data sets to be able to be consumed. So with the advent of new technologies, that's becoming a bit easier now. There's a lot of interoperable tools, but the work to connect them up is still a work in progress, I think. And largely in the geospatial world, because geospatial data are massive and are big to deal with, and you're dealing with satellite images and ground collection data, putting them together is a pretty big task. And that's one of the places that I think requires a bit more kind of effort.
Yeah, and it seems like a lot of the stuff also happens on the fly when suddenly someone discovers a data set that another organization needs, and then it's like, how do we share it? Do we do it through AWS? Do we do it through Azure? Do we do it through Google Drive? What's the best way of getting the data to the right people sort of as fast as possible?
Yeah.
Oh, it's fascinating, right? And Gisborne at the moment on the news, I mean, the far extreme is there's no communications.
Yeah.
So actually they're back to delivering newspapers to every letterbox. So I mean, we've still got that element going on to think about, practicalities on the ground, right? Why? So if we think about some of the core challenges, right? Like everyone knows these challenges exist, and they exist in day-to-day life, BAU as well. Why do some of these things exist, and why is geospatial often, it seems so difficult?
So in my experience in the past, working with like kind of data collection aspect during emergency management, usually the people on the ground collecting the data are not necessarily your kind of geospatial experts, right? So they need tools that are pretty easy to use and should be pretty efficient to use on the ground during emergencies. You can't have any like complex apps because you're out there collecting as much data as quickly as possible. So the folks on the ground collecting the data may not be geospatially savvy. So the design and development of those tools requires a lot of geospatial aspect going under it. Then after that, once the data is collected, once that comes back into the system, the people who are the IT operations or anybody who's collecting that data are also probably not geospatially savvy, so they are using standard data management practices to kind of store that data. And then when the data gets used for analysis, that's when the geospatial experts come in, and that's where the overhead happens. Is you got to now translate all of this data that's not collected, maybe geospatial friendly, to make it geospatial, so that I can use it in analysis. So that's one of the challenges that I have noticed, I guess, in the past.
Yeah, well, I guess if you look at what's happening in Gisborne at the moment with the communication blackout as well, even if you collected that data and communicated it back out, how do you make key decisions on that?
Yeah.
You know, and it may come down to scribbling back on a map. It may come back to radioing, using the local ham radio clubs to sort of communicate to and from the area and trying to disseminate information like that. So the communication part of it becomes even more important, because now you're trying to communicate spatial concepts and spatial data in a non-spatial way down a radio. You know, and that's another pretty interesting twist on it. How do you make that data as communicative as possible outside of its visual aspect?
Yeah, and also when you're doing analysis, a lot of the analysis is happening, you know, using statistics and statistical models. The complexity in understanding statistical models itself is pretty big. And then how do you communicate the result of a statistical result, right? You know, sometimes you're saying that it's, you know, or the particular model is saying that this particular event has the probability of 90% happening 98% of the time. Like, how do you communicate that in a useful way that people can make informed decisions?
Yeah.
Because these scientific concepts and these statistical models are already hard to kind of model and create. On top of that, to be able to understand it and then communicate that to make key decisions is even a harder aspect. And on top of that, you're adding geospatial modeling in addition to normal statistical modeling. So that adds another layer of complexity of understanding and then communicating that.
And not only from the spatial side, but also from the SME side, the people who are looking at this data and trying to understand what's going on. You might be able to say, look, we've got a map and it says the corner of the river by Smith's Road, you need to keep an eye on that. And someone on the ground might go, actually, I've been there, I know that spot. Yeah, that makes sense because it's flooded in the past. And so it is getting, you know, that information communicated to people who can understand it, or communicating in a way that someone who isn't a subject expert can understand it.
I mean, I think that's it, right? When time is the currency and there's not much of it, when you're responding to events, it's a decision to support tool. At the end of the day, someone needs to make a call on something. And so I think what you just said, K2, is how do you provide that context and the view of the stakeholder you're engaging with?
Yeah.
And actually, five decimal points of accuracy
Doesn't matter.
Doesn't matter at all. Is it, you know, it's I need to do something, I don't need to do something, or hey, let's hold, you know, green, red, you know, medium, orange.
And in any of these things, you know, what needs to be done is triaged on a list, an ever shifting list up and down. This is more important. Oh, well, actually, this has happened. This is more important now. So being able to sort of have the ability to make those decisions with enough background knowledge about it is essential for any sort of rescue, whether it's a single person out of a cave or whether it's a multi event like we're seeing in the North Island at the moment.
It's interesting. I've just been reflecting on, I mean, often there's the whole we keep tin in our basement of a regional council in case of an emergency event and power's cut or whatever's cut, right? But actually, if the power's gone, if the comms are gone, you're not communicating with anybody anyway. And you can't bring in satellite data if that's all gone. So that concept actually of the cloud and thinking about what that means, but having that proper understanding of what can happen on the ground, right, and understanding how to support that. It's quite an interesting concept to think about, because now with the advent of more constellation, so let's take SAR, for synthetic aperture radar from space, and its potential to do with good processing pipelines, you know, near real-time flood modelling and mapping. Obviously, that can be done remotely through the cloud and disseminated anywhere that's got comms.
Yeah.
Sort of reflect on that thinking. particularly pertinent right now.
Oh yeah, exactly. You know, we're dealing with a major weather storm, and if anyone's seen it, there's that amazing photo that Net Service pulled up saying, you know, New Zealand landed along a white cloud, Aotearoa, you know, and 3/4 of the country is covered in the cloud from the cyclone. SAR plays a role in it by being able to work in areas where it's obscured. You know, you can't use optical satellite imagery, no matter how high resolution it is, if everything's covered in cloud. So SAR is taking a big part of that. It's an active technique that basically fires microwaves out and it illuminates the subject itself. That gives you elevation change, it can give you surface change. We've done a little bit of work looking at detecting flood extents using it. And so because these constellations over the last 2 years have become more and more available, the data's become cheaper and cheaper, and that temporal cadence of when it's capturing the images is increased. To some of them it's multiple times a day. It's becoming sort of the go-to data product for emergency management as well. You know, we've just seen Maxar yesterday have chosen one of the big SAR suppliers to be integrated directly into its catalogue. For things like this, when there is an emergency, you can get high resolution imagery. If you can't, you've also got high resolution SAR available.
That's really interesting. I don't know, Santosh, if you then think about the operations happening in the field, intelligence coming from that data pipeline, SAR for instance, remotely cloud disseminated, you know, that ground truth thing you just talked about before, like that is so important, right? Like, hey, the data's telling us this, but as soon as it's ground truth or we have some validation of some form, which could be a photograph of the GPS location, for instance. I don't know, but how does it all feed together, come together, standards, interoperability, the right tools to the right people?
Yeah. So if I just step back a little bit and address the earlier question about, you know, if emergency management organizations or councils or whoever, you know, are the current practice is to keep a tin in the basement so that in matter of emergencies, if you lose connectivity and if you lose power, then yeah, the tin becomes useless because obviously you have no power. But the advantage of using the cloud aspect of it is if it is in the cloud and even if you don't have power, means let's say, you know, assumption that all of New Zealand loses power, so you can't do anything in New Zealand. But if it's in the cloud, that's accessible across anywhere in the world. Mm-hmm. So other scientists or other emergency management folks can pick up that, do the analysis, and push the data back into the cloud. Then after that, when, you know, somewhere like in New Zealand where you don't have any power, if you want to access that there are other ways to communicate that information. Mm-hmm. So for example, if the analysis is done and it's sitting in the cloud, even if somebody in Australia or Europe or anywhere or Asia can analyze and disseminate the information, all that's required then is just to communicate that to New Zealand somehow, either through satellite phones or something like that. There are channels there. Maybe you can't send large chunks of data using those mediums, but you can at least send communicative messages.
And I think the flip side to that is, this is the first time when there's kind of been an event where Starlink has been in, where people have got, and I mean the emergency management groups in New Zealand do have satellite internet modules so they can do it, but they're off the shelf, battery powered.
See, I love this stuff. This is this intersection of all these megatrends of technology going on, right? So great articles, in Hastings I think I saw one, guys with EVs, right? They're powering their entire house on an EV. It'll last for 20 days, keeping the fridge going, keep comms going. Yeah. So again, none of the stuff's sort of in isolation together. And all of a sudden, these pieces of technology between Starlink, comms, high-speed broadband, essentially from space, with batteries and a solar panel, you're almost self-sufficient. Yeah. And then you're reflecting again on points of failure. Oh, cool, tin in the basement. But actually, just 3 weeks ago with the Auckland floods, floods go into the basements. Yeah. Where are the generators? In the basements. Where's the mechanics that do the 30 stories of lifts up and down a building? It's in the basement. So everything died anyway.
Yeah. So now that the intersection of these technologies are coming together, that then brings me to the current point, which is the value of standards. Mm-hmm. So if you have different organizations, different entities creating these technologies, in order for them to communicate to each other, you need to have a standardized way of communicating. You can't have different data formats, everybody coming up with their own formats and storing stuff in their own way, because that just creates more overhead every time you want to access the data, process the data, analyze the data. So that's why I think the value of standards are very important for communication purposes, first and foremost, either machine to machine or even human to human. We need to have, just like how humans have common language so we can understand each other, data needs to have common standards so that tools can understand them in an easy way. So yeah, so that's where I feel standards are very important, and the importance of metadata as well, how the data is being collected, what it's being collected for. And again, all of this is pretty technical itself, and then the way to communicate that is another layer, is how do you communicate this information in a useful way. So
yeah, that metadata one's pretty important, and something I'd say most of us don't do well.
Yeah.
You know, we make the data set and we called it untitled something.
Final.
One, final 2, final 3. But the metadata that goes along with it and actually says what it is, why it was created, what it's used for, what period of time does it represent, is so important when you're trying to sort of navigate through the kind of the wealth of data that falls out of all of these organizations. And they might all have different metadata standards, they might all have metadata or not have metadata, and so that's just another kind of break in the cog that can slow things down, because now you're trying to not only, you've got the data in your hands, you can kind of see what the data is, but you don't know the provenance, the time expiry on it, which can be critical in these kind of events.
I mean, and we've, because of what we do here with AI in particular, you know, that bias, because you've got that core repository of data, the raw data coming in from wherever it might be coming in from, that itself has bias and assumptions and limitations, and that clarity of what they are as respect to the downstream data processing. Because you see it all the time, right? There's assumptions on this raw data, we're joining 3 things together through a data pipeline, but actually those assumptions are just compounding, assumptions on assumptions. And so the clarity of that, because at the end lands an API or physical map that someone makes a call of.
Yeah. And people usually take what comes on a map as pretty much a given. A classic example of this is, don't quote me on this, but I think if you go to Google Maps, I think they say something like 90% of that data is accurate up to 98% of its location or something like that. A classic example is, we all know that the prime meridian goes through the Royal Observatory in England, but if you go to Google Maps and you zoom in, the prime meridian is actually a few miles west of the actual Royal Observatory. And that's not, you know, and when you look at the map, you would think, oh, why is the prime meridian going through west of Royal? It's not, it's because of projections and other kind of warps that's happening when you're displaying the data. So, but as a normal person who doesn't have geospatial knowledge would look at that and would think it's wrong, right? So that again comes down to how do you communicate that information. If you don't understand the details of the metadata or how the data is being collected or how it's been displayed, you can get some really wrong messages across, and it could be pretty detrimental.
Another thing that always comes up in these is like, everyone has the ability to run some form of GIS on their phone now. You'll carry around Google Maps, you know. How do you kind of start leveraging that out in a way where the kind of citizen science sort of aspect of it, where you're crowdsourcing emergency data into a central network, you know, and that's another thing. How do you even start with that? How do you build a system that starts collecting this data and not only having to worry about its provenance and its accuracy in the time domain, but also collecting this data and handing it back to people within the same metrics, I guess. It's, you know, it's a hard thing to do, I think, and it's, while the technology is increasing, we still sort of somehow always stumble over the same problems. How do we get data in if we need it? How do we assure that the data is correct? How do we get that data out to people who need it quickly?
I just recently, I've seen it all over LinkedIn, and I saw it a while back too. NIWA's got, is it flood photos or flood map or something? Like a crowdsourcing thing where you just take photos of floodwaters, obviously GPS location, but that becomes pretty interesting, right? If you're thinking provenance and sort of longer term modelling prediction, pretty cool. The next step is how do you automate, you know, the results to come out of that? Like, that's another question. But you're sort of right, that citizen, you know, how does everyone in an open, interoperable sort of crowdsourcing way get to play a role in sort of a country's response effort in this case? Yeah,
there are some good initiatives that's happening there. I don't know if you've heard, there's things called like Ushahidi and CrowdMap that are working towards creating the systems where it can be, you know, you can use your phone, you can use SMS, you can use other ways to transmit data. and that gets put into some database. But again, it requires quite a bit of skill set to then disseminate that data, and it's not as easy as it should be, especially for emergency management purposes.
Yeah, you need like a Waze for emergency management.
Yeah, or like a Google Maps or something like that. Yeah.
I mean, there's things like I know I think it was USAID funded maybe with the Nepalese earthquakes, a Kobo toolbox or one of those open source sort of. Yeah, it's got some sort of foundation like that. Which was particularly, we can't have a heavy geospatial app on everyone's phone because everyone's got a super cheap phone, right?
Yeah.
So lightweight location, that's all we're doing. Real basic, easy to use for everybody.
Yeah, and the other great initiative in that space is also the OSM HOT, which is a humanitarian OpenStreetMap effort. And that's a great idea because every time there is a natural disaster, either USAID or one of these bigger kind of emergency management organizations would trigger an hot event, and then mappers around the world would go in and they would map, and the data is now available within OpenStreetMap immediately to be used for other purposes. So there are initiatives that are happening, and it just needs a bit more drive and a bit more effort behind it to kind of make it more mature.
Yeah, and I mean there are commercial companies that recognize that the data that they are collecting is highly important and timely in those things. When we see Maxar has their emergency response page where as soon as someone reports a major response, they start downloading imagery and putting it in a bucket that you can get for free, which is a pretty important tool because not only is it high resolution, but it's also very accurate in time as well. At that time, it's the closest imagery they can get to it, and it's free. So countries that don't have the ability to drop 200, 300 grand on a task satellite coverage of an area, the ability is there for them to get that data straight away, as well as all the open source, open access satellites like the Sentinel series from the ESA.
I mean, when I reflect back on, obviously here in Christchurch, and we had the big earthquakes, 2010, 2011, the Kaikoura earthquakes, the response not long after, so often the infrastructure has to get rebuilt again, right? The data and technology infrastructures to enable, the response and post-event work. Why is it the case? We learn, but we don't. And every time we build it from scratch again, it's a big... And I think part of it is in the old traditional model, if you're not using the cloud, you need tin and you're standing up tin that you don't use with the extra capacity for the chance that you might need to use it, right? And then all of a sudden an event hasn't happened for 5 years, the tin's outdated, the versions are out of date, whatever. But surely there's a better, smarter way now with the cloud, responsive on demand, elasticity, sort of have the containers, the systems ready to go, push a button, they scale, boom.
I guess something that covers multiple governmental organisations. So in New Zealand, FENS, government, police is government,
the Defence Forces,
government, St John's is charity. So now you're trying to interact systems between a whole bunch of organisations as well as government organisations and external NGOs or charities. So therefore you need something that gets driven at the government level to sort of say, right, how do we build an infrastructure that if something happens, everything's virtually in one place. We can have the ability of getting data to the correct people. We have the data, we have it so it's pretty much set up, so we don't need to go, oh crap, we need to suddenly get all this data from here to there. We need that. And I think that's from being in Christchurch and seeing the problems between inter-organisations all over the place, and just the scattergun craziness of communication that happened because something this big hadn't really happened before. And I think we should have learnt from that, but I kind of feel some of the learnings have come through, especially into organisations from FENS through the coronal inquiries on the earthquake. But I feel it could be done better, and I feel like it has to be done at the kind of almost at the nationwide level where you have an infrastructure to say, we open the tap and all this data goes everywhere that it's needed.
Yeah, and that's a good way of thinking about it. Like we need like an organizational or like a human conceptual model of how we need to spin stuff up for a particular emergency management response. But if I take a bit more philosophical step at it and you look at the technology aspect of it, historically, I don't know, 60, 70 years ago, people were doing the same thing, but they were doing it with pens and paper, right? They were collecting this data and then that was somehow transmitted to different people to organize for emergency management. And then computers came along and then we started putting it into computers, in these massive supercomputers. Now technology has gone into PCs, then now we've got servers, then we've got now cloud technologies. And as the technology changes, even though our human concept, the organizational concept of how do we spin stuff up for an emergency can still be maintained, because technology is changing. This is something in the tech world we call them as like, what is it called? It's called like choice anxiety. Like for example, if you go into JavaScript, there's like 10 libraries that you can use to do the same thing. Which one do you pick? Or if you go into like, coding, there are 10 different libraries to do the same thing. Which one do I pick? The same thing happens in technology is every time technology changes, you have to upgrade your organizational mental concept of how this is going to be put together and then translate that into technology.
Yeah.
So before we were doing it in PCs, now we got to do it in servers. How do we do it?
Yeah.
Then now we got cloud. How do we do it in cloud?
Yeah.
So because that technology is changing so rapidly, to keep up with that is a challenge. But again, this is where cloud technologies, again, like things like Kubernetes and things can come in, because you can standardize not just at the data level, you can also standardize at the application level. Yeah. You can say that an emergency management application, you can define it in a YAML file to say, this is how I want a emergency management application to look like. Yeah. And it's going to use these kind of features and these kind of libraries and tools. And once that's standardized, then it'll be a lot more easier to then replicate and deploy the required technological resources you need to address an emergency management situation.
Yeah.
So I think it's a two-pronged challenge. One is how does organizations keep up with rapid changing technology? So you have to keep standardizing and abstracting that standards to a higher level beyond just data, from data to tools to applications to organizations. And then on top of that, how do you keep up with the ever-changing landscape of technology itself?
And
at the code level, yeah.
And if you think about the earthquake, how many of us thought prior to the earthquake that we leave our computer and we walk away and we start somewhere else on a different machine? So many people I knew, because I was doing my PhD thesis at the time, and so many people were just like, I left my laptop at uni and ran out. My laptop's at uni. I don't get access to it for 3 months, 4 months. So between, and that's how many years ago now?
A decade
ago, 12 years. Between that and a COVID, I think people have completely embraced the idea of being able to chop and change, move from one place to another, and the data is always accessible no matter what computer you're on, no matter what type of device you're on. There's the ability to access that data and do predictions, do modeling, etc.
And the scale even goes even higher, or the stacks go higher when you go into like global kind of problems, right? Like, so for example, these are localized kind of natural disaster problems. They already, you have loss of life, you have also loss of property and damage and things like that. But then if you look at something like a pandemic, where you're trying to manage or address it globally, not just locally, not just in the New Zealand context, you want to manage. Because, even though if New Zealand is safe, how long are you going to keep everybody logged in? Eventually you're going to have to open stuff up and people are going to have to mingle. So not only standards between organizations within a country,
but also localizations.
Within countries. Exactly. So it's quite a challenge.
I mean, I think actually we've talked a lot about sort of acute events, kind of. If we step back, and we've talked a lot in the business around climate change and how we can help, I guess. But just take, it's sort of the canary in the coal mine, right? The globe at the moment, really. It's happening around us, and some still don't believe it. If we do believe it, everyone's sort of paralyzed as to what do we do. It's making it relevant, right? So if we think about the amazing science that goes on in agencies like the UN Met Service, all around the world, the data's there, the prediction's there, the model's there, but they're caught up in these massive scientific models, data formats, NetCDF, whatever. that ability to again cloudify that, which in turn makes it accessible. You're driving the insights and the knowledge dissemination, and then the presentation layer to make it relevant to people. I mean, why? Surely we have to go there again. It's back to, again, cloud standards, interoperability, APIs that work for everybody. Why are we so locked up still? Particularly in this realm of science, deep science, right?
I think there is, scientists build models. That's, depending on what you do, you build some sort of model, and every model has some sort of confidence interval of how well it performs. And I think going from an output of sort of some science, which is a known error in it, and communicating that outside an organization, I feel there's some sort of risk without that error being communicated that this is a model, we know it's 80% good, it works in these kind of conditions. Unless that is 100% clearly communicated to the end users, decisions will be made without them going, actually, this error says that this model should be going this way and this kind of thing, and it's going the other way. What do I believe? And I think that is, from the science side, I think there is some, not reticence, but I think there is an exception of risk that gets involved with taking science and communicating it and make decisions from it.
I mean, most scientists I speak to and meet, they want to, they're doing it for a reason, right? They're trying to learn more about the world, whatever domain they play in. They want to share those results. Typically it's in a scientific paper, journal, whatever that means. But again, it's that silo. So you're kind of right. How do they share it with the assumptions? They don't want to lead to a wrong decision being made because someone didn't understand the science.
Now, if you step outside the scientists and you start looking at, the managers, the CEO of organizations that do it, if you've got a product that has some element of risk about it, even if that risk is known, how confident are you about releasing that out? If you know that decisions are going to be made from it that could fall in that 20% of the model not working. And I think that's more of the, I think the ability to communicate the risks is the problem going through, and that's being probably held up at the organisational, the institutional end, where, the risk goes to the board.
It's tricky, eh?
And I think that is one of the key things in sort of doing that. You're completely right. All the science is out there.
I mean, the flip side to it is kind of what the world's going through now in the last decade is paralysis analysis. Like, actually, we're doing nothing.
Yeah.
Nothing changes. So again, how do you... Yeah, it's interesting. The science is there, we all know that, but it's not permeating down to drive behaviour change at the individual level if we take,
And I'll say the science was there, because the day that project finishes and the output is released, that output is a snapshot of up to that time, depending on the type of analysis, depending on the type of prediction. But unless that is kept up to date, it's always going to be a data set that is calculated within a certain period for a certain time slice.
It's that project lens, and we talk about this too, Santosh, a lot in terms of the amount of innovation projects, POCs, proof of concepts. They don't see the light of day beyond that innovation project budget, because it's too hard to move it to production. There's no owner, we don't have the right tools, technologies, cloud, licenses, whatever it is. Again, it's kind of similar. A project ends, science wrapped up, but if that model, that science, that analysis was living in production, the value it can potentially add is enormous.
Yeah, and I think the disconnect there, I feel, is, the scientists kind of work in their world. They are very knowledgeable in their domain, but they're not there to productionize their science. That's not their role. Their role is to search for more knowledge, advance the knowledge on a particular subject. How that science gets to people is the role of the organization or communication or somebody else. And because in our current world we are so, the way our organization is structured, the way our jobs are structured, in order for efficiency, we've kind of created these specialized roles that people just do their thing and they stay in their boxes. Once the scientist has communicated his science, how does that get articulated into, first of all, the person consuming that science needs to understand what he or she is consuming, then to be able to write a story around it that is helpful for decision makers to make decisions is a specialized skill in its own, and that's now becoming more and more relevant in today's world. Maybe it was not as relevant 15, 20 years ago, maybe because the scientists were doing both the jobs, maybe, I don't know. But that's something that I've found hard, is how do we communicate that science? That's always the challenge.
And if you look at something like the working groups for the climate change documentation,
IPCC.
It's the IPCC working group 5 or whatever. The science and the science behind climate change. You know, it's a incredibly well written document, and it's probably one of the most peer reviewed documents on the planet. Not only do you have 1,500, 1,600 people contributing to it, you've probably got a layer of 10,000 other people, both scientists, diplomats, you know, governmental people, going through not only analysing what it means, but how it's communicated.
Yeah.
So when they say there's a higher than likely chance that this, you can go to the back and it'll say a higher than likely chance means this is 80% or greater. You know, they're matching the language that's coming out to make sure that it's coherent across the board, every one of those chapters, and in multiple languages.
Yeah.
So it is completely written in the concept of the communication layer between the science and the end users or the readers, the consumers of the data, is so controlled that it's you know exactly what it's talking about.
I mean, the communication, right? Everything's communication. But it's, to your point earlier, Santosh, you were talking about languages. And, you know, whether it's human language, you know, English to English, whatever that is, you know, you can communicate through a means of understanding between each other.
Yeah.
So we'll talk about that at data level. The systems application level is really interesting. But actually, is there a more fundamental thing that if we're thinking about the tying together, not only of the data, but of the story, location. Can location actually, is it the universal translator in a sense to all of this? That's the relevancy, that's the common, the glue to tie it all together, but also be the means to make it relevant to end users.
Yeah. If I go back to the concept of scientists and what they're doing, again, they are working in their context. So let's say, for example, if like an emergency up in the cyclone, if somebody is focusing on the flood modeling, they're focusing on flood modeling, right? They want to get that flood model to be accurate so they can get those boundaries and get them out as soon as possible. But the impact of that flood requires an additional level of analysis about the economic analysis of flood, of the property damage analysis, the population displacement analysis. All of those things need to happen on top of the science that's happening with regards to flood management, right? So now that is, and all that information is required for you to be able to communicate that. And because the science itself is so complex, you know, like we were saying, we were talking about the CPCC report or the IPCC report earlier, if the science and the information in itself is so complex that even the more you dumb it down or the more you make it more simpler, you might lose some information which might be dangerous, right? So, yeah, I mean, I guess one thing is us as humans probably need to increase our intellect to be able to understand these documents.
Well, actually, it's really interesting point. So, complexity, the world is complex.
Yeah.
You know, we still can't model it.
Yeah.
But yeah, complexity made simple. In other words, not dumbing it down, but yeah, how do we get better at communicating complexity?
Yeah.
In a simpler way, but not by removing it or hiding it.
Right.
Yeah.
Yeah. And that is a hard skill because not only do you have to understand the science, you also have to understand like human psychology to be able to write these stories and narrate them in a way that's A, you're communicating the right thing, B, you're writing it in such a way that the right emotions are coming out for users so you can actually change behavior. Right? You can communicate things easily, okay, fine, but people need to read it and to be able to be impacted by it so they can change their behavior requires another layer of human psychology put into the writing and communicating that information.
Took about 2 years for me to explain to my parents what my PhD was on.
Yeah.
And I had to go, it's like toast. Toast goes in a toaster and it gets heated for a certain amount of time and it comes out and it's a different colour. That's what I do.
It's a bit different than
And us in the GIS world can understand that. Like for us to explain what we do itself is so hard. And it's not. Like, it's been an industry for the last 50 years and people are still struggling to understand what geospatial is and what GIS people do.
GIS magic.
Yeah.
I mean, yeah.
So,
it's interesting. I mean, isn't it as simple as understanding and modelling the world and human use and interaction with it?
Yeah.
I don't know why we all get caught up with geographic information system. I mean, what does that mean?
Yeah.
It's a bunch of tools down there to manage some data, It's pretty interesting. For the storytelling and the relevancy, we did some work and some thinking with some of the local councils, I think it was last year, just around how you knit everything together from a community-driven sort of digital twin / smart city / urbanization concept, right? And there's multiple themes across that. But we talked about outcomes and KPIs. And when you think about it, I don't know, you've got social, you've got cultural, you've got environmental, and you've got economic lenses across every decision, essentially. And different decisions at different times with different people will have different weightings across that. So I think, I don't know, there's something in there that we need to get better of. And it's also that unintended consequences thing, which actually comes back a bit to the science thinking we're talking about. If we put it out there, someone might make it cool, there's an unintended consequence. But actually, how do we get better at transmitting that and translating that and saying, well, this infrastructure project that's going to put a railway line through here, it's going to have these economic benefits, but it's going to have these disbenefits. That clarity of the holistic thinking of geography, really, is so often lost because of silos. Actually, it's just lack of communication using the same language.
Yeah. This is where I like to plug Obvious. Because I think the importance of data-driven narratives are very important. So not only is it about getting the right data, to be able to, right now there are already tools and technology available out there that you can narrate stories with data sets, right? So as data is changing, so that's a skill set that us in the GIS world has been playing with for the last 20-30 years, creating maps. A map itself is a story. And so we are constantly in cartography, and we're using skills in cartography and analysis. We are constantly trying to communicate a story through a map. But now I think that requires a bit more narrative added to it at a data level. So now we've got the technology and the power that users can go and click and drill down to a particular data value on the browser. And if you can give it the story at that level, so at every data point, if you can associate a story with it, I think that will cohesively increase the understanding of the science. Because science, at the end of the day, when a paper is published, it's got an abstract, and an abstract, most people end there. They got to read the abstract or read the headline, and they kind of leave it there. I don't know how many people actually drill down to the nitty-gritty science of it. But this way, if you make it more interactive and if you make it more kind of a rich user experience to understand the science, then that's probably a way to go about communicating complex issues and information to the public.
And we have kind of started, and this has been going on for a long time, this is what I call Cartography Plus, which is, the infographics. How do we take these complex things and draw pretty pictures that people can look at them? And I think of Minard's, is it the 1817 Napoleonic trip into Russia, which has distance on one axis, it has temperature on another axis, and it shows the amount of people who started and the amount of people who came back, with horrifying effect of that cold winter. And Florence Nightingale, of course, with her graphs of World War I casualties of how they died, whether they died in battle, whether they died of injuries from the battle, or did they die of infections, And she was one of the first people who really sat down and started trying to figure out ways of visualizing this over the war. So that kind of concept of how do we take information and put it in a non kind of linear way is probably our biggest problem now. We can put things on graphs and X, Y, everyone can see that, but how do we start allowing people to interact with that data? How do we start seeing the trends between bits of data without being locked into a standard Cartesian XY graph.
Yeah. And how do we give people ability that in simplest terms, I mean, now we've got AI, we've got natural language programming, things like that, how can we use those kind of technologies to leverage and combine them with geospatial so that people can ask questions and then you can go and do the analytics in the back, combining the science, combining the narratives, putting them together and providing them a cohesive story for the end user so that's easy for them to consume.
ChatGPT.
Yeah.
Yeah. Taking the world by storm. I mean, this has been pretty wide-ranging, pretty awesome conversation. Something I've been thinking about a lot lately is, this precision thing, which kind of back to the science around the absolute accuracy. In a pictorial sense, if you think about satellite imagery, extracting features, using AI, hey, the pixel's not quite right, that sort of concept. But actually, isn't the time aspect of it kind of the equalizer?
Yeah.
Because really, when you think about it, 80-20 rule, the science, whatever it is, but time will equalize out some of these errors to naturally go, well, the trend is going up or down.
Yeah.
That's kind of more important to know than that was perfectly accurate with 5 decimal places or the pixels were right or whatever that might be. I don't know. And I know we're focused on thinking a lot more temporally now lately too.
Yeah, I mean, it's definitely always been a thing that I've been very focused on, change over time. And I guess there are tools that are allowing us to do that now. A lot of people are doing change detection. It's one of the change detection and introducing AI into the mix, has become a massive way of semi-automating observation using different techniques. So even though it might only be a 70% accuracy, it's a flag that still allows the human in the mix to go and have a look at it. And I think it's the accuracy versus precision argument that we see all the way through science. I think precision is becoming less important for a lot of the things we see. We're not worried about the 5 decimal places, but we are worried about the scale of the results. Are they correct in multiple variables compared to, if I measure it in 10 decimal places?
Yeah, the robustness of the results is more important than the precision of the results. Yeah.
Yeah, and the building footprints extracted from imagery, is always a hard one because every piece of imagery has a distortion in it, and I remember we had one client we talked to and they were like, so how are you calculating the offset of the true height of the building in this imagery? And we were like, well, I don't know. Is it that important that your building footprint is, out by 0.5 meter because of the barrel distortion of a optical imager, and it was for them, but for 98% of people who aren't surveyors, oh look, that's the house that was there before. It has an area of this.
I mean, it comes back to understand the purpose of that data, right? So we're back into that. Why is it being collected? What are the assumptions around it? Yeah. And if you need survey grade, like bet your life on it, turtle stations, we're still there. But actually, if it's just to understand the digital twin and the sort of footprint of, building cover versus canopy cover across the city, hey, there's satellites and aerial data.
Yep. Are you needing that within a 0.5 meter accuracy? No. So something that's captured at a meter resolution of the data, and that's not spatially, that may be the value it requires. Might be fine, and other things they might not be. So I think it's understanding the purpose that what the data's for, and being, and that ties it back into the communication is giving a really clear set of guidelines, not so much guidelines, but opinions about where that data should be used and how that data should be used and communicate it. And that comes down to all the flooding data, the flooding models, And I think if there is that kind of clear way of saying this data is good and this might be alright in this kind of application, might not be.
Yeah.
These are the risks. Opens that data up a lot more.
It's a classic sort of Venn, right? So you've got the cost, the time, and the accuracy, and you can't have it all. You can pick 2. So if we reflect on that work we're doing at the moment with Sentinel-2 for the whole country, right? 10 megapixels, multi-spec. Lots of other folks in the years gone by have tried to do it with aerial imagery, which maybe you can get more accuracy, precision, however you define it spatially, but actually Sentinel-2 flicks over every 5 days. And you know, we're pulling out shelter belts from 10 meter pixels at 86% odd accuracy.
Yeah.
And actually that's good enough because we can now do true annual updates all the time of data that's existing, open data made and built for applications like this.
And again, you know, trying to find in a country like ours, especially in the last few weeks, trying to find cloud-free imagery is impossible.
Difficult.
You know, it's very difficult. So I have to trawl through a year worth of data at every pixel and sort of go through and say, you know, how many of these pixels have cloud in them? Can I use some sort of statistical aggregation on those pixels once to clear the clouds off it, and then again make sure that there's no clouds within it to build it. So every pixel is anywhere from, you know, 40 to 170 pieces of data that go into that, which is filtered down to produce a cloud-free, you know, a cloud-free image for New Zealand. And that gives you quite a good change on a year-to-year basis, whether it's an average change or whether it's a median change. But if you start looking at those smaller periods, which people are interested in, what happens in summer, what happens in winter, it starts getting more complicated because the amount of data that you've got to ingest into the model is considerably smaller.
Yeah, and it's a good point that people should, you know, again going back to the concept of what data should be used for what purpose, right? Like for example, if you do want that survey grade analysis, then there are different data sets for that. If, you know, depending on your use case, what you're trying to do, understanding which data can be used for what is very important. And again, if you're not coming from a geospatial background, or if you don't have that knowledge base, then it's really hard because things like Google Maps have made it easier to zoom right from space to my ground. People just assume that anybody can do it. And we've gotten requests where people wanted to pick sheep from satellite imagery, or people wanted to pick, you know, like building boundaries from satellite imageries. And like, you know, if your sheep is 10 meters, yeah, we can pick it. You know, but your sheep is not 10 meters, so we can't use satellite imagery to pick them, you know. And so it's like, yeah, it's definitely understanding the use of data and understanding what data can be used for what purpose, understanding scale, understanding resolution. You know, these things are taught or learned at a very geospatial centric level, but I'm hoping that going forward in the future, you know, things like spatial resolution, temporal resolution will become part of just normal data thinking and data management processes. Because most, you know, database admins or data managers or data processors probably are not aware of things like spatial resolution, of things like temporal resolution. You know, temporal resolution probably is a bit more common, it's a bit more people are grabbing their head around it, but spatial resolution definitely is kind of this hidden magic knowledge that only geospatial people know. And that needs to be opened up so that it just becomes part of normal data metadata, not just spatial data metadata should become part of just any data set's metadata. You can have null, but it should be included as part of any data set. So it can be...
Hey, look, as we look to wrap up, and obviously we've given the audience a bit of a taste of the conversations that happen around here every day downstairs. I don't know, do you have a thought, an insight, something to leave the audience with? You know, it's been a pretty wide-ranging conversation. I think if I wrapped it up, it's about standards, but actually it's beyond that. It's around how do you engage in good communication using known interoperable or interchangeable languages, right? And that's both at the human level, that's at the machine level, and this context of geospatial is the glue. Anything left to share?
Yeah, I guess it's moving away from data for data's sake into data as a product is a pretty big thing for me. Is make a data set that is fit for a purpose, and that is communicated through along with the data set.
Yeah, I guess the last takeaway, I guess one of the parting thoughts, I guess for me is a lot of great science is happening, a lot of great knowledge is being created, and there are tools out there now with cloud and whatever. There's tons of tools out there to kind of productionize those sciences. I think now what excites me is how can we use these tools to now bring that great science to the masses so that people can make either have rich experiences so they can change their behavior and understand their world better, and B is how can decision makers use that same tools to make more important and key decisions and make them quicker and in a timely manner.
It's all about data to information.
Yeah. What do they call it? They call it farm to table. So this needs to be from census to policy, I guess.
Yeah.
I discussed a bit earlier on a podcast the whole DIKW pyramid, so data, information, knowledge, wisdom, and the whole feedback loop, right? Hey, once we've gone through that tree and presented the data, conveyed the knowledge, driven decisions, you get a bit wiser, for better or worse. And it might be that data's not fit for purpose. Let's spin back, let's have a look, let's change it, let's tweak it, let's play with it.
Yeah.
It's that positive feedback loop we need going on to get the flywheel spinning.
Yeah.
Thanks heaps for your time, lads. It's been an awesome conversation. Thanks, audience, for bearing with us here, and we look forward to talking to you in the next episode. Thank you.